Welcome to today's video. We're going to talk about proportional relationships today, and that's just really a fancy way of showing different patterns within different pieces of whatever we're looking at. So if we read this today, all a proportional relationship is really a quantity or some amount corresponding to a quantity of another amount. And ultimately, proportions, we have to have something we're doing to one quantity in order to get an additional quantity. And the reason why they put it in, say that it can be represented in a table, because it definitely can. So for example, if we start off with pounds of chicken, like they've said here, so we have a proportional example, 3 pounds of chicken, and we represent that with our cost. We have 3 pounds of chicken, and they say that that represents $7. So ultimately, we can find a pattern for how much it would cost for 4 pounds of chicken, 5 pounds of chicken, and so on, if we knew the unit cost of 1 pound of chicken. Okay? Unit cost. That's an important term. All a unit cost is how much does it cost for one. Okay? So how could we find how much it costs for 1 chicken? Okay, well, we can set up a proportion. So if we have pounds of chicken over our cost of chicken, that's going to equal, in a proportion, pounds of chicken over cost of chicken. Okay, so let's start with what we have. We have 3 pounds of chicken cost $7. How much will 1 pound of chicken cost us? Well, we ultimately want to get X by itself because we're trying to find X. But we have to figure out how do we get this X value knowing that we're going from 3 to 1. How did we get from 3 to 1? Using either multiplication or division, because that's what we're ultimately using here. Good, we divided by 3. So if I divide 3 by 1, divided by 3 by 3 to get 1, whatever I do to my numerator, I have to do to my denominator. So if I divide 7 by 3, what do I get? Well, I get 7 divided by 3, which is 7 divided by 3 is going to be the cost of 1 pound of chicken. So how do we go about doing that? Well, it's just a simple division problem. 7 divided by 3, we know that that is around $2.33 with a repeating bar. Okay, so now since we know what 1 pound of chicken costs, we can then find a pattern or proportional relationship for how much it's going to cost for each additional pound. So if 3 pounds cost $7, but we know that 1 pound costs $2.33, we can add $2.33 to $7 to get how much 4 pounds would be. So that would be $9.33. And ultimately, what it's trying to tell you is when you have a proportional relationship on a graph, we're going to have something that's linear that goes through the origin, which we will see on the next page here. So, if 0 pounds of chicken costs $0 and 3 pounds of chicken costs $7, we can figure out the proportional relationship without finding unit cost by just adding 3 pounds to find what the whole number cost would be for those pounds of chicken. So if we go from 3 to 6, we know that 3 costs 7, so doubling that, it would cost us 14. And you'll notice here we're just graphing it on our graph. So 0, 0, we have there. 3 pounds of chicken costs $7, which is on the graph. 6 pounds of chicken cost $14, which is on our graph. 9 pounds of chicken cost $21, which is on our graph. And our last point here is 12 pounds of chicken equals $28. You'll notice here we have a nice linear relationship when we're working on proportions because our rate of increase is constant. Okay, so the relationship between pounds and cost in this example is what we call proportional. Moving on to another example. So this is an example where zero games does not cost anything. We have a non-proportional relationship. Okay, so an arcade game costs $5 to enter and is $1 per game. So we have a base cost of $5 regardless if you're playing a game or not, because that's your entry fee. If you'll notice on our graph here, all we have is we still have a line, but we now start at $5 because that's our base cost. Our base cost now is not 0 here. It actually increases to $5 as it said in the example. Let's go ahead and read this paragraph together to get some more understanding. So the relationship between games and cost is not proportional. Because, for example, someone who plays 4 games, which cost $9, does not pay twice as much as someone who played 2 games, $7. There is no multiplier for this relationship. The graph does not go through the origin. So that's something to recognize. You're not going to have a proportional graph if it does not go through the origin, because ultimately your multiplier is not going to be the same. I know this was quick. Proportions for CC3 should be a review. If you're still having questions, be sure you access the proportional videos from earlier classes. Again, if you understand proportions and how to use them, go ahead and like today's video. Thanks for watching. See you next time.